Okay, good afternoon all. So you are welcome to this course. This is MC 310. Okay, I think I've introduced myself in the physical classroom. My name is Engineer Dr. Kenneth Samuel Mbon. The course is Electrical Circuit Theory. Electrical Circuit Theory, MCE 310. It's a 300 level course hosted by Mechatronics Department now, that is MCE, at Federal University of Technology, Owerri, Imo State, Nigeria. Now, I've given you a course rep, the course objectives, the course material. The textbook we'll be using is Electrical Circuit Theory and Technology. Electrical Circuit Theory and Technology by John Bird. John Bird, the revised second edition. Course objectives. Course objectives. After going through this course, the students should be able to, 1, develop an understanding of the fundamental laws and the elements of electric circuits. You'll be able to learn the energy properties of electric elements and the techniques to measure voltage and currents. Be able to drive appropriate models for RLC circuit responses. Number 4, you'll be able to develop the ability to apply circuit analysis to DC and AC circuits. And then you are expected to understand advanced mathematical methods such as Laplace transform. You've done Laplace now? Good. We'll be looking at the applications. We just hope that we will have all the time to look into some of these things. Fourier transform, along with linear algebra and differential equations. Learning outcomes. After going through this course, you should be able as a student to understand basic electrical properties. That's number 1. Analyze electrical circuits using many laws, Kirchhoff's voltage law, superposition principle, Norton theorems. You should be able to do that. And you should be able to find circuit responses using Laplace transform. And then understand signal superposition. Please, I don't want you to have that attitude of let me read this in and pass the exam. We're actually dealing with basic things that control some of the things you use. When we talk about engineering and science, you notice that we are talking about resistor. What again? Capacitor. What again? Inductor. If you can understand the way these 3 things work, I mean, you can analyze anything. For example, now, transformer. If you pick up a transformer, what is there? The coil is a what? It's an inductor with a what? With a resistor. And nothing more. That's the basic thing there. So, you open up any electronic circuit, you notice that it is these components connected together that are being used. It's just that even if we don't have the technology to produce them at very minute microscopic level, nano level, but at least if you can understand the basic principles that guide their operations, it simply means that you can at least come up with something. I believe in the young generation. So when we look at the principle, you have to follow it. Why it's important that you pass your exams, but don't limit yourself to the what? To the exams. The textbook that has been recommended for the course is holistic. So what I'll be doing here now, what we'll be doing here now is look at the basic principles that control some of these things that will help you understand the course when you read. I've already discussed the way the course will go in the class, so I don't need to repeat it. Now, we'll be looking at resistor in parallel, voltage source, in parallel. There's parallel resistor, series resistor. There are basic things you must understand and bear in mind. When do we say a resistor is in parallel? You did your physics now. They're interconnected together. Come and show us. Okay, he says when they are joined end to end, they're in parallel. Is that correct?
No.
So who has something else? What's her name? Anthony. Okay. Is this one is in parallel, right? This one is in series. Why do you say this one is in parallel?
The circuits, they are set to parallel because the resistors are connected parallel to each other. That each resistor is connected directly to the voltage source, not one another. Because in a parallel connection, when the voltage comes, it splits and goes into each respective resistor. Whereas in series, the voltage passes through each resistor, dropping them gradually through each resistor till it leaves the final.
Okay. I don't totally. You tried, but that's anyway. That's why you are here. That's why we are here. I want to say something that you don't need to forget. We say that resistors are in series